Thanks, sir.
Thank you so much. Thank you. So good afternoon. It's nice to see all of you here. And it's really my great pleasure to be here at D.I.C.E. This is my second time to be here at D.I.C.E. And last year I came here, and I thought it was probably the best conference I went to all year in terms of how much I learned and all the different people I met here. And I'm from Qualcomm, and we make processors that go into a lot of the smartphones that are out there in the market today. We know a little bit about gaming, but mostly we spend our time thinking about how to make chips and how to make processors. So compared to all other talks you've seen today, it's going to be a little bit different, and hopefully you'll find it useful. But I love games. I love games like everyone else here. I have something in common with all of you. My favorite game, the one I used to play a lot, was Tetris. I was awesome at Tetris. Contributed to one more year of grad school for me, playing Tetris too long. And then moved on to a few other games. Tried my hand at some of the bigger games like Call of Duty and so on. But like some of the other speakers before me mentioned, when your 10-year-old starts beating you, then I think you can start moving along to new games. And now I'm playing Fruit Ninja. So it's great to see the people talk about Fruit Ninja today, and nice to see all of you here. We do a lot of work on processors, and what I'm going to do today is talk to you about the work we do on processors and how it's going to impact what kind of games and the creativity of the people in this room. And I believe that there's a lot of great things we can do as we work closer together. So let me switch gears here and talk to you a little bit about Qualcomm. Qualcomm is not a very well-known name, although now in these parts towards the west, I think it's a little bit more known. And I remember when I first was at Qualcomm, I used to travel a little bit, and I told somebody once I'm with Qualcomm, and they said, "Oh, you're with the stadium. Can I get tickets?" So that's actually what we're really known for. But we're actually a pretty big semiconductor company now, and as you can see the stats behind there, we've been very fortunate. We've been in the sweet spot of one of the largest platforms that has ever happened, which is actually the mobile platform. And a little fact that you may or may not know, we actually ship more GPUs and more CPUs into the mobile CPUs and GPUs than anyone else now. So we have one of the largest number of GPUs out there. And we design our own GPUs, so I think it's probably something important to talk to people in this room. Now, having said that, we really are not a really great household name. We have this great convention that goes on every year in San Diego called Comic-Con. I go there all the time, and we don't see anybody dressed as Snapdragon. We keep looking for it, but not quite working yet. But we do see a lot of other ones that the people here make. Snapdragon is the processor we make, and it's the processor that's inside the majority of the smartphones today. What we do in gaming, now gaming is actually becoming a fairly large, and in fact, one of the key factor when people buy a smartphone. We at Qualcomm, before smartphones became popular, we started working on something called Brew, which is an operating system that is kind of the early smartphone type OS. So we work with a lot of game developers and a lot of other app developers. It's a very successful platform, over $1 billion in revenue for various partners of ours. But what we find now is with the tremendous growth of the iPhone and the Android phones and the Windows phone and so on, gaming has become a key factor. I saw a statistic just the other day that said 78% of the people with a smartphone now play games in the US on their smartphone. The statistic is actually even more compelling in some of the emerging regions of the world. In China, it's 92% of the people with a smartphone play games on that. It's actually a stunning statistic if you think about that. And the revenue, is slowly but steadily increasing in amount of opportunity for the developers to make money in mobile gaming. Now, a lot of you might remember this is actually one of the first games that I'd like to say, if you were to draw a line and say, this is when mobile gaming started, maybe like Snake. A lot of you remember Snake. Maybe 1997, I believe, was when this one was popular. A lot of things have happened since, and then there was a product that came out, which I actually have one of them here. This is the famous Nokia N-Gage. Some of you might remember this product. This is a product that I actually worked on this product in building the audio solution for it. I was at Texas Instruments at that time. What's great about this product is while it was not a market success, it actually was a product that said gaming is important in mobile. And the market will happen for mobile and gaming, to the point where Nokia was going to modify the form factor of the device so that it was more like a gaming device. It's a really prescient device for its time. But since then, I think things have really improved, and we've got some tremendous traction in mobile, and the games have steadily improved. So today, we just got this clip from this screenshot from Epic's Infinity Blade 2, just a gorgeous shot of what's possible now in mobile processors. From Snake to doing this in a few years is pretty phenomenal, what we've been able to do. And if you look at that, what I'm going to try and do is maybe talk to you a little bit about how that has happened, and what is it that in the wireless industry we've done to enable these kind of stunning graphics to be possible on a battery-operated device. So let me talk to you a little bit about what are all the things that go on in the phone. If you look at the phones, one of the key things that has changed over the last few years is the screen resolution. Actually, while it sounds like a simple thing, it's the screen resolution, it has more impact than any other vector in the phone. Today, the screen resolutions that we support in our mobile processors are in the order of 2560 by 2048. Now, just a few years ago, when I was working on this, VGA or half VGA or QVGA were the screen resolutions. So the fact that we can support 2500 by 24 by 2000, which is much larger than your 1080p TV, by the way, and we render to that screen on a lot of the new products at 60 frames per second. So the performance of the mobile processors is already beyond what's required to render on your TV right now because of the resolution of the tablets. And that's because it's drive for dots per inch, because you hold this thing closer to your face, you want more density of pixels. Now, to be able to do that, you have to drive tremendous amount of memory bandwidth to get the data in and out. Just a few short years ago, we were talking about megabits per second. Today, we'll be driving pretty soon 25 gigabytes per second through our mobile processors to the DDRAM, to the DDR. We looked at CPU speeds. We were at a few hundred megahertz not too long ago. Right now, most of the phones that ship using our processors have quad-core processors, and each CPU runs at 1.5 gigahertz. And at CES, we announced our latest processor, which will ship this year, as 4 processors, each runs at 2.3 gigahertz. And GPU performance similarly has been doubling every year over the last few years. So if you look at the amount of processing power that we have packed into these devices now, it's actually pretty stunning what you're able to do. And that's what leads to those gorgeous-looking games like Infinity Blade, and there are many others like that. Now, the other aspect of it is it's not enough in mobile to have great processors. And processors is one aspect of it. But then the phone is something that's connected all the time. And when you're connected all the time, I was listening to many of the talks today. One of the gentlemen said, the immediacy of mobile gaming. I thought that was kind of an interesting way to talk about it. And that's really what it is about. When you're playing games on mobile, there is an immediacy factor. And to get that, you not only need great performance, you need high-speed networks and great bandwidth. So in the wireless industry, we've been working on that pretty hard. It's not too long ago, we were on GSM and edge networks at a few kilobits per second. On the LTE advanced networks that we drive today, that we launched this year, we are at 150 megabytes per second to your phone. That's what we'll be launching here. And right now, we run 40 megabits per second on your LTE. The new LTE advanced standard will be running at 150 megabytes per second. At 150 megabytes per second, you can stream 4K video to your phone. Real time, 30 frames per second. So that's the kind of processing we're driving, and you'll be able to run it on battery. We will run them at all-day battery life. So when you do that, if I were to put a little contrast and say, I know there are a lot of references to Pong today, and maybe I'll add mine. So if you started Pong as the beginning of console, and you look at today the console games, and you look at Snake as when the first mobile game was, and you look at the things like Infinity Blade as the state-of-the-art of mobile gaming, I think in 16 years, we've kind of made that tremendous amount of progress on mobile, which is very telling. Now, why is that? Why is it that we were able to make so much progress so much faster? I think one of the key reasons is actually just the explosive growth of the market. Mobile is a huge platform, and there is an opportunity. It's a tremendous, and a lot of the innovation is happening in mobile because of that. Now, there's lots of great innovation that's happened in console games. If you look at particularly on the interface side, and the talk before me from Ubisoft was very interesting to see the timeline of all the things that have changed. From simple things like analog joysticks to D-pad to force feedback to multi-screens and so on. That has changed a lot on how things interact with games, particularly with motion controller, with Kinect. But mobile is a little bit different. Mobile is different because it's also inherently social. And it's always with you. I mean, it's a phone that you have with you or a device you have with you all the time. That creates a lot of other ways that you can interface with it, and a lot of interesting games that you can create, and a lot of interesting use cases of how the games can now be built. Now, mobile, the other thing that's happened in mobile is that the numbers are actually staggering. And if I just mention a few numbers to you, for those of you who don't spend a lot of time thinking about it, except, hey, you see smartphones everywhere, it has become the largest technology platform in the history. So last year, there's actually now 6 billion connections of mobile phones in the world, and growing. Last year, the wireless industry shipped about 500 million smartphones, and that's growing at the rate of 40 to 50% per year. Now, that is a tremendous business opportunity, and when you have an opportunity that big, when I go to shows like the Mobile World Congress or CES, you can just see the amount of innovation going on in that area and all the new technology that's coming into mobile first. Now, not only that, there's another aspect of mobile. It's actually the most loved technology platform. Now, what do I mean by that? A lot of people will share their console. They'll call friends over, and you can play their games for a while, or they'll loan you a game, and you can borrow their game. Probably even let you drive their car. But I tell you, nobody lets you borrow their smartphone. Just doesn't happen. And if you lose your smartphone for some reason, or you misplace it, I mean, you should just see the way people react when they lose their phones. It's actually a phenomenal thing to watch. It's like the whole world came to an end. And so it's actually the most loved platform. It's something that you just can't do without. And I can see a lot of you nodding around and everybody looking for their phones to make sure you got it. But it's that kind of a product, and it's a great product, and people love it. Now, it gives you unique opportunities for new game designs. And what do I mean by that? So actually, the talk by one of the gentlemen today, I guess Amir Rao, who talked about multi-platformization. I thought that was a great talk when he talked about porting a game from one platform to the other is just not going to get you the real experience of the game. And that's kind of what mobile is all about. When you actually think of moving a game from somewhere else to mobile, it just creates a new opportunity, a new dimension of how you want to do the game. Because the fact that you want to operate with one hand, and that touch as the interface, itself changes a lot of things. Now, if you think of games like Words with Friends, and Draw Something, I don't think those games would have ever become very popular if it wasn't for mobile, because you have it with you all the time, and you can play turn-by-turn games. Turn-by-turn games on a console are really boring. So I think that's actually something to talk about, how social and turn-by-turn games have really happened in mobile. And it gives you a great opportunity for creativity. Now, I want to change gears a little bit and talk to you about the kind of things that we are doing in the wireless industry and the kind of technology we're packing into phones that you will see in the next few years. But just to give you a feel for it, what happens is when you're in the mobile processor business, typically for us, we think of making a processor, and we start defining the spec. And it takes us about 6 months to define the spec. And once we get the spec and we actually start the design, it probably takes us another year, at least, to design it. And then the fab takes another 4 months nowadays, and the chip comes out. So now you're at least 18, 19 months into getting from what you thought you wanted to what you have as samples. Then you give it to your customers. They work on it for a year and a half to do all the software. So by the time the product comes out, it's at least 3 years out. So anything I'm working on now is probably what you'll see 3 years from now. So, but it's important to talk about the kind of things that we're working on, because that's the platforms that will be out in these multiple hundreds of millions. So almost all of these platforms, and the reason I'm mentioning this is this should hopefully give you some information to think about all the creative people in this room and what kind of games and what kind of interactive experiences you can design when these things are available to you other than just a one input device. So almost every phone now has GPS built in. So location and context you always have. You always know where the person that's playing is. We are building in a lot of computer vision into these games, into these phones now. So by computer vision, I mean things like FastCV and OpenCV, libraries will be inside that. So you can track objects, detect objects, find motion, find the depth of the object from the screen, and so on. Most of them will have multiple cameras. Many of the phones that we work on now will have over 18 sensors, from proximity sensor to altitude sensor to touch sensor to gyros to motion sensors. The phones are actually just packed with sensors when we build these. Most of them will have multiple cameras. Almost all of them. The new phones we're working on all have 13-megapixel cameras and 2-megapixel HD camera facing forwards. We will be enabling these phones with gesture control. So you will be able to just wave to the phone in the camera, and you can control the UI. The kind of experiences that you're thinking about from Microsoft Connect and that kind of devices, you can get them on the phone. So there's lots of interesting things that we're packing into these phones, and you'll be able to take advantage of that. Now, there's another challenge that comes when you do this is the network bandwidth. The network bandwidth, as I mentioned, although we've done a tremendous job of growing the bandwidth, when I talk to some of the operators, with the way the connected devices are growing in the home, I mean, there's probably soon you'll have 100 IP addresses in your house. And actually, that's not an exaggeration. You probably will have it pretty soon. I already have multiple tens by now. Gone are the days when you could have one IP address per house. And when you do that, when you have so many devices connected, most people think that in the next few years we'll need 1,000 times more bandwidth than what we have today. The demand for data bandwidth is doubling every year. So what are we doing about that? In the wireless industry, we're working on 3 different things. One is called spectrum access, where instead of reaching into the spectrum on one radio, we can do it on multiple radios and combine them, so we actually get much higher throughput. Another one is network efficiency. We're actually working on a technology called small cells, where actually you'll have a base station which is about that big, and this base station sits in your house, and it becomes a local area network. It connects to all the other base stations. If you're driving around the neighborhood, you'll be able to hop from one base station to the other that's in people's houses in a secure, safe, managed way. That's how we'll actually increase the bandwidth quite a bit. We'll aggregate the Wi-Fi and the power line and LTE networks into one, so you'll get much higher bandwidth. So a lot of things we're working on there. Now, can we continue at this rate? I mean, is this a speed at which we can continue the innovation? Absolutely we can. There are many things we are doing. If you actually look at the CPUs in the mobile industry, in the last 2 years, we went from single core to dual core to quad core in 2 years. And if you see the amount of time it took the PC industry to get that kind of rate, it's been much, much longer than that. The GPUs have doubled in performance every year. And what we are working on now that you'll see in a few years is the concept of heterogeneous compute. What heterogeneous compute means is if you take one of these mobile processors, there's CPUs in there, there's GPUs in there, there's DSPs, there's video engines, there's camera engines, there's so many different components. But when you write an application, when you write a game developer, you have to kind of think about where each of those things is going to go. Where is sound going to go? Where is graphics going to go? Where is video going to go? The technology we're working on in the next generation processors is that you don't have to worry about that. You write your application and automatically figures out which processor it should really go to. And that's the concept of heterogeneous compute, when you can optimize the best part of your application to the most suitable compute element inside the processor. Now, the other thing we spend is we spend a lot of time on getting every ounce of performance out of these devices. As I mentioned, the new devices that we launched at CES actually have the ability to do 4K encode and decode. So I'm talking about a 4K camcorder in your phone, real-time 30 frames per second on battery operated, which actually is ahead of most of the 4K content on the TVs. So we're actually going to drive quite a bit of that. And you're also now able to play full 7.1 surround sound. And not only that, you'll be able to play that through a pair of speakers, so you can really make virtual surround happen. So if you're a game developer, you should be thinking about how do you drive that kind of quality onto a mobile device or a tablet so you can have that immersive experience wherever you are. Now, one of the other key problems actually is in addition to building these great products, you got to get the access to these products to the consumers and the game developers. So we spend a lot of time on building SDKs. We spend a lot of time on building APIs and profilers At Qualcomm, since we build our own CPUs and GPUs, we actually build our own tools also, and we support the development community with that. And we also are now launching an SDK called Snapdragon Sdk, which gives you access for things like noise canceling, things like camera tracking, things like face tracking. So you can just incorporate them directly into your game without having to write the low-level primitives to get all those operations. And those are some things that we are making them available, through APIs and through libraries in the phone. So you can start development at a much higher level than worrying about the lowest common thing. So I'll end on a last note, which is the biggest challenge. The biggest challenge for the mobile industry is actually battery power. We do all this, but we want these things to last the whole day at least. I think we've trained the people to charge their phones in the night. I think we've been successful. Now we need to make sure that we're able to make the phone last the whole day independent of how you use. And we're spending a lot of time on that. Our GPU, actually, the latest GPUs double the performance of the previous one, but actually much higher performance than the previous one. And the battery consumption from the GPU itself is half. So we're now able to drive the performance higher, but drive the power consumption down. So we're spending a lot of time on that. We do asynchronous multi-cores and a lot of different things to get the power down. So I'm going to run out of time here. On my last slide, I really wanted to say thank you once again for AIS for giving me this opportunity to come and talk to you guys. This is not a forum where you're used to probably seeing chip guys talk about processors. But I thought it's very important for you to at least listen to the kind of things we do, because when you look at the opportunity in front of us and the fact that we built this huge platform, which is the largest platform, and all the creative people in this room, when we get this kind of technology this kind of innovation that can work on the technology that we built, I think the next generation games, as someone mentioned this morning, can be a lot more different genre and a lot more different types of games, and expand the audience that play these games, so that it'll be a great business opportunity for us all. Thank you.